So my Windows boot just stopped working. I think there was like something with a bad NVIDIA driver update along with a bad Windows update. Um, so I was like, if I had to reinstall it, I have to set up everything again. I might as well just walk you guys through it. The reason I decide that we need a new tutorial is because when I look back on when I started programming, the tutorials and stuff that I looked at, they all worked fine. They all worked great. You would have a nice setup running at the end of it, but I wouldn't understand what the hell I just did, right? Like I wouldn't understand all the things I installed were, what the buttons we pressed did, and because I didn't understand those things, I struggled to pick up and try out new things or um, just make my environment malleable to my use case at the time because I didn't understand what my environment was. So my goal is to make sure you guys understand what we have so that when you guys become more advanced users, you guys can modify it, switch it up without being too confused, Googling a bunch of stuff on like Stack Overflow or other websites. And because it's meant for newbies, this tutorial, I'm going to be yapping a lot, right? Like I'm going to be explaining a lot of things that may seem trivial to you. So if you're experienced, I'll just leave timestamps so you can skip around or you can watch another video. But if you're new, hopefully this helps. So the first thing we're going to need is a compiler. So the C and C++ programming languages are not understood by the computer. They are understood by us, but the computer only speaks ones and zeros. So, in order to get the binary that we need for the computer to run our programs with, we need a compiler called GCC that translates those programs or the program that we write into binary for the computer to run. So, in order to get GCC, well, there's a few ways to do it, but this is my favorite way. I like using MSys. Well, let me explain what it is first. So, MSys is like this Linux adjacent environment that you can get on Windows. Um, the reason you want this is because as you guys get more and more advanced, you're gonna find a lot of value in using commands like awk, tar, um, grep, find on Linux, and it'll also give you that experience later on, to where you know a little bit of the Linux environment. So if you ever have a job later on that involves you using Linux or some other goofy environments, you have the capacity to use these tools. So this is really nice for that reason, but it also gives you a package manager. So like on Windows, for example, which we're doing right now, like I have to go install something, right? So I have to Google it, and then I have to get the installer, and then I have to do all that. A package manager on Linux is essentially you type 3 words and you get the thing that you want. So like if on Arch, if I wanted Firefox, I'll just type pacman-s Firefox, and then I'll have Firefox, right? So it's kind of nice for that too. So that's why I like doing it this way. So we're gonna get the installer. I'll leave a link down below. You click this. I already have it installed, which is why I'm not doing it. But then you're gonna go to just type in MSys. This works. And you're gonna get all this stuff. So we're gonna use UCRT64. I think it stands for like Universal C Runtime. This is for like Windows native applications, meaning whatever we download is native to Windows. Um, Minji W64 is like programs that were not written for Windows, but they were like ported over for Windows. And then ARM 64. ARM is like if you're using a different architecture CPU. I'm on x86 64. Most of you are probably on x86 64, so you can probably just run with that assumption. But if not, you can just go to like your about PC. You can go here and just like Google what your CPU is. Right, like it'll give you the name and then you can Google it, or does it even tell you? I'm not sure. Yeah, I mean it says x64, so you have that. Okay, so let me open this guy back up. I don't know why I closed him. And so you're gonna type in a command called pacman-s. I think I actually have it queued up somewhere. Yeah. Okay. Okay. So pacman is invoking our package manager. Um, and then dash s is telling, hey, I want to use my package manager, but I want to use the install functionality, right? Because pacman doesn't just install stuff, it can also update stuff, it can also delete stuff. So I have to specify I want to install, and then these are the names of the packages. Okay, so GCC is the compiler, which I already explained, and then CMake is our build system. So what is the build system? What is CMake? CMake is this cool tool that helps you describe to your compiler where files and things are. The reason you're going to want that is because when you write a program that's only one file or two files, like you can make that work. But when you get numerous files, like when you get this large program structure, your compiler is not going to know what to really do with all that, and you're not going to really know how to tell your compiler what to really do with all that. So CMake is like this really simple language that you basically do those things. You describe where things are, you describe how to link things together, and so at the end of it, you have like maybe 200 files that you condense into one binary executable that your computer can run at the end. That's what CMake does. I'm not going to go over CMake too much. Um, Maybe I can give like a quick tutorial at the end, just write a quick script for like one file, but you're definitely gonna want this for later. So we have that. We're gonna go to File Explorer. We're gonna go here. We're gonna go here, right? So File Explorer, local disk, and then MSys64. Okay, then we're gonna go to UCRT64 because that's what we downloaded. And then bin. Bin means binaries. You're gonna see that a lot when you program. Like if you're looking at someone else's project, you're probably gonna see stuff like this. So bin is binaries, stuff that you can run. We have all this, right? So C++. I think I saw GCC somewhere. GCC is 100% sure because we installed it. So we're gonna copy and paste this directory, and then we're gonna go to the environment. Right, if I can there. Okay, we're gonna click this. Actually, first let me tell you why I'm doing this. The reason I'm going here is because if I type GCC right now, okay, well I already did this actually. I forgot. So let me just force the error to happen because you guys are not gonna have it already half set up like I do. Okay, now the error should happen. Okay, so you see, like this is what you're gonna be having. You're gonna run it and you're just gonna be like, well, it's giving me an error. Why? Because even though you have it installed, your terminal doesn't know where to find it. So you're gonna need to tell your terminal where it is. And so that's where Windows environment variables come in. So we're gonna go here, we're gonna go new, include this path. And yes, we do have to reinstall or restart the terminal every time we edit the environment variables. And so there you go. We have GCC, right? If it's spitting out the version, that means we know it is installed. And then we can do the same for CMake because we installed both. So we have both CMake and GCC. If you're new to the terminal, clear, obviously clear is a thing. I think Control L does too, does it? Yeah, Control L does too. So now we have both the things we need installed. So now I don't use Visual Studio Code, but if you guys are new, I highly recommend you use Visual Studio Code to at least start with. Like you can use something fancy like NeoVim, but NeoVim is a very complex editor that is probably going to be too much for you if you're already learning a new language. So just you can always move on to something new after this, but I suggest use Visual Studio Code. So let's just make like a simple C program, okay? So stdio, and I guess since I'm doing this, I can explain to you real quick what the code is. So stdio, it's like standard input output, I think is what it stands for if I remember correctly. And so the reason we want that is because we're wanting to use a function that is only included within this. So like header files in C like describe definitions for things. So if I use something like printf, for example, right? Like, did I ever describe to the program what printf was? Like, if I hover over it, it has like the definition right here. It's because the definition is included in this header, which is standard to C. And then yeah, return 0. I mean, it's an integer. You don't really need this because I'm pretty sure you don't need this, but it's a nice habit to build. Like, it's returning an integer, so just return 0 at the end of the function. And then obviously print hello. So like, where's a nice play button? Like this is not gonna work, I'm pretty sure. Yeah, like there's no nice play button. How do I get this to run? Well, the easiest way for me to do it is, so cd means change directory, And where am I gonna go? Well, let me actually make sure I save this first. So where am I gonna go? I want to change directory into this path. And so now my terminal's basically in here. And I'm gonna do GCC. And then the name of the file that we want to convert into binary, which is main.c. And then I want the output file, right? Because it's not going to replace this file. This file's still going to be here, but it's going to read the file, and then it's going to output to a file we'll just call main. You can call it anything, bro. You can call it like 6.7. Okay, you're going to get a file called 6.7. This is literally binary. So don't worry if it's a bunch of useless, weird junk like this. It's supposed to be a bunch of useless, weird junk. Like, it's not supposed to be readable. You're not supposed to be able to edit it. So we have that. And then we can do... I don't know if this will work on Windows. Is this how you do it? Yeah, okay. So this is the command on Windows to execute a basically a binary file. And so it just prints out hello. So that's pretty much a gist of setting up C and C++. If you want to, I can demonstrate a C++ file, main.cpp. Okay, then we're gonna do include IO stream. This is basically like C++'s version of stdio.h. Include IO stream. We're gonna have kind of like the same thing going on, except it's gonna be like stdc out Fortnite. Okay, it's actually funny that I spelled it wrong. And okay, and then return 0. Same idea. We're gonna have this main.cpp, and then we're gonna, since this is a different file, we don't want them to have the same name. Why is it giving me that error? Win main. Oh, because I didn't save the file. Yeah, I'm not editing that out. Okay, there we go. G++. So GCC is for C. G++ is for C++. And then the same sort of thing. So that, and then 69 Fortnite. Okay, so that's how you set it up. Okay, so like I said, I was going to show you guys how to use CMake, because this is like going to be the main way in which you build and put stuff together. It's not going to be you just manually invoking GCC, because a lot of projects are going to have more files, and that can really facilitate. So I went ahead and just created like a quick library int poop, okay, and then I include poop.h. So remember, header files just clear, like, have declarations in them. So it's saying there's a that is not a function. That is a function. I accidentally declared it as a variable. That would have been bad. Don't do what I did. So I declared a function, or defined a function called poop, and then I said what it's going to do in here. And then I just created like a quick script in C that just takes the response from poop, and then it prints the response from poop. This %d, in case you're still new to C, like, this is like how you have printf format things in different ways. So it's saying like print it as like a decimal, right? Because it's a number. You can have it like format hexadecimals. You can have it format like obviously letters. So that's that. So how do we actually get CMake to do what I wanted to do? So remember what I said, like CMake is a build system at the start. I was actually kind of wrong. It's a build system and generators. So CMake is kind of like this consolidation slash simplification of like older build systems, because it actually used to be more complicated to do this. So some people came together and said, hey, let's just simplify it. Let's make a really simple scripting language that generates the build system for you so that you don't have to go through all that. So once it generates the build system, then with that build system, can you compile what you need to compile? So CMake list.txt, this is always going to be named this. This naming convention is not optional. So the way you use it is, first you're going to define the minimum required version. So you're going to say like version, I think they're on 2.1 right now, 4.2.1. It doesn't matter. You can use an older version. You can use the newest one. It doesn't really matter. It's also going to be the same. And then we're going to name our project. So project will just call poop. Okay. Actually, there is something else I want to do. So You know how the compiler doesn't know where everything is? Like it needs to be told where everything is. It needs to be told how I want to link everything together, right? Like the compiler is kind of blind to what my project is, so I need to tell it. Visual Studio Code kind of works in the same way. Visual Studio Code doesn't actually understand what your project is unless you tell it what your project is. Like right now, it's working fine because they've done quite a good job. Like IntelliSense is decent at guessing what everything is, but as your project gets bigger, you're probably going to be like including stuff that actually are properly defined, actually exists, but it's giving you like error messages, even though you know they're right. So in order to avoid that, you're gonna want to tell CMake to generate a file that you're gonna give to Visual Studio Code. It then reads that file and then understands the structure of your project, and then it accordingly adjusts like the different error and warning messages. So I need to tell CMake to generate that file. So it's like let me look at my cheat sheet. Export compile commands. Yeah. Okay. So we're gonna turn this on so that when we generate the build system, it's gonna generate the file as well. And then we're gonna want okay. So actually for the sake of the tutorial, I want to show you guys some like really cool stuff that you can do. Let me write this out because typing and or thinking and talking is hard. Okay. So like I said, like CMake helps you put a bunch of files together, but it also helps you have like unique configurations of your project. Like you're not always gonna want like one binary file at the end of it. Like sometimes you want a file, um, you want something called a shared library. What is a shared library? You've probably seen files on Windows. I think they're called like .dll. I might be wrong, but I know on Linux it's .so. But basically, it's a binary file, kind of like what we've been generating before, but it's meant to be used by other binary files. So at the end, when I make my poop.exe, which is just a binary file, poop.exe is going to then use another binary file called my library to get the definitions, right? So we're going to have two binary files, one called my library and one called poop. Poop is using my library um, to do its functionality, right? And so now we need to do a target include directories. And so we're going to say my library. Hold on, let me type this. And then, sorry, I'm not used to not having Vim motions. Current source dir, right? Yeah. Okay. So, we now need to give the library like our include file, right? Because like so far we just only told about our C file, so we need to give it our like include directory. Include directories like are typically where you're gonna find the header files. So if someone says like an include directory, just know it's likely gonna have a header file. Um, and so I told it where it is. And then public meaning like okay, when my poop.exe tries to go to my library, it needs to know where the definition for the functions that it defined in my library is. When I say public, it's saying give poop.exe the knowledge and access to this stuff, right? Because if I make this private and poop tries to do something with the poop function, now that I realize it, the project should probably not be called poop because that's gonna cause confusion. Let's call it like okay, 49. 49. Let's call it 49, okay? 49 is gonna need so 49 is we're gonna have two executables, 49 and poop. Okay, 49 needs the ability to go into poop and look at these definitions. So I said public so that way 49 knows about it. Okay. And then add executable. Add executable meaning like I want to generate 49. Okay. Like this is gonna be our executable that we run. And then we need to tell it that we are linking the library. So we simply do 49 private. Well, you don't have to do the private, but I guess I can explain this to you. So private in this scenario means like, okay, 49 knows about my library, but if someone else uses 49, they don't have to know that this exists, right? Because like the idea is like if you're using 4.9, you don't really need to care about this library because it's already using the library. But if I want someone that uses 4.9 um to know about this, and I'll just put public. Okay, and this should be, let me double check this. Looks good to me. So we make a folder called build. Okay, you don't have to do this way. I just like to keep the build files organized. We're gonna cd into build. Okay. Um, Now in build, well, we're gonna want to like invoke cmake, but the cmake file is obviously like over here. It's not in build, so I'm gonna go up a directory, right? Because remember, dot dot means to go up a directory. So cmake is gonna go here, find this, generate that. Did it work fine? Yeah. Okay. So this is a thing that I was talking about. This is what Visual Studio Code needs to know what the hell is going on. Okay. So how do I give that to Visual Studio Code? You're gonna need an extension, this guy here, because that'll give you IntelliSense and debugging for C++. And so how I got to here is I did Control Shift P, or you can, I don't know if there's another way to do it, but Control Shift P should get you here. Then you're gonna do C, C++, edit configurations, and this is gonna generate a file that Visual Studio Code uses to understand certain things about what you're doing. And then you're going to do compile commands, and then you're going to give it the path to this guy here. So copy path. Okay. It's red because of two reasons. One, it wants double backslashes, or I think it can also just take one forward slash, but if you use backslash, you gotta have this. Okay, and then it's also complaining because we need a comma here because it's JSON. Okay, so let me make sure I save the files, right? Yeah. Okay, so now the IntelliSense knows about the project, so Visual Studio Code knows about it, and now our compiler knows about what's going on in our project. So now we're going to, I'm gonna hide this, and now we're gonna actually build our project. So cmake build everything in here, linking c executable poop.exe. Okay, this, okay, yeah, see, it is a DLL. So lib my library.dll, and then we have our poop.exe. So poop.exe, yeah, it just returns 6.7. So you see what happened is poop.exe looked into my library. Wait, why is it generating poop? I thought I renamed it 4.9. Oh, because I don't think I saved it. Okay, well, you get the point, right? I confuse the naming stuff, but we have a library called my library with a function called poop, and poop.exe looked into my library to get the definition of poop, the function. Could have done this a lot better, but you get the idea, right? It's like this is going to be like how you're building projects most of the time, and like that's why it's not as easy as, hey, let's get a run button or like some play button in the top right.